Hello, my name is SN Patil. Here we discuss the course Integral Transform. So before proceed this course, we discuss the prerequisite, which is very useful when we come across the integral transform course. First of all, here we have to know the periodic function. A function f of x is said to be a periodic function if there is the smallest integer capital T such that f of x plus capital T is equal to f of x, then capital T is known as a period of that function, which is also called fundamental period or primitive of the function. For example, sin x, cos x, sec x, cosec x, these are the periodic function of period 2 pi. In this function, these are the f of x is equal to sin x. When we put x is equal to x plus 2 pi and apply the formula of sin a plus b, then we get f of x plus 2 pi is equal to f of x, that is the 2 pi is a period of the function. Similarly, tan x, cot x, these are also periodic function having period is pi. Okay, now see the 2k pi means k is an integer. This is the generalized term, generalized period of the sine function, cosine function. Of now, let us take another example of constant function. Constant function, there is no fundamental period. In a constant function, we add any number, we get the right hand side is as it is. We get the right hand side is f of x. Okay, so in constant function, it has no primitive period. Okay. Now see the next. F of x is periodic function of period t. Then f of nx is also periodic function of capital T by n, is also periodic function of period capital T by n. For example, sin x having period is 2 pi and period of sin 3x, that is n is 3, that is t is 2 pi, that is 2 pi upon n. Okay. Now next, even function and odd function. A function f of x is said to be a even function if f of minus x is equal to f of x, and odd function if f of minus x is equal to minus type f of x. For example, cosine function, sec function, even degree polynomial. These are the even function which is symmetrical about the y-axis. Sine function, odd degree polynomial, tan function, these are the odd function. Now exponential function. Exponential function, these two definitions not satisfied. When we put x is equal to minus x, we don't get the f of x here minus time f of x. So exponential function is neither even nor odd function. Now see the some important formulae which are very useful when we solve the problem. Okay, these are exponential into trigonometry formula of the integration. Now in this unit, in this course, instead of simple pi parts, we use the generalized y parts to integration of u into v is u into v1 minus u dash, v2 plus u double dash, v3 minus, and so on. The suffix term indicate integration, and dash term indicate order of the derivative. Okay, the selection is very important. Select the term for u such that it should be a vanish after the rth derivative. Okay, now next, reduction formula. So here these are the reduction formula for cosine and sine for the limit 0 to pi by 2. Now the reduction formula for multiplication of both. Okay, and these are the simplified form. These two formulae for 0 to 2 pi and 0 to pi. Okay, now in this course, here the condition is very important. When both are the even function, then we write 4 times, otherwise 0. And when we find the integration under 0 to pi, that time only check the condition for power of cosine. If the power is even term, even, then we can write 2 times. Otherwise, immediate write the 0 term. Okay. Now, next, Euler formula. Euler formula, e raised to I theta is equal to cos theta plus I times sin theta. And e raised to minus I theta is complex conjugate of e raised to I theta. Now, trigonometry function, these are the useful while solving the problem. Okay. Now, the definition of integral transform. The function is defined on the interval a to b. Okay, this is open interval. Then script f is, we consider operator, is any operator. Okay, operate on the small a, f of x, its image we get the f of k, and defined as integration a to b f of x k of in bracket x comma k dx, where the k of xk is called as a kernel of transformation. Okay, there is a different rule for the transform of kernel. When this kernel is simple exponential function, then we call this term as a Laplace transform. When the kernel is Euler formula, then it becomes a Fourier transform. When it is a x raised to k minus 1, then it is a Milnor transform, integral transform. Okay, thank you. In next lecture we discuss about the Fourier transform. Thank you.